Going to get started on one of the most confusing and misunderstood devices, which is, you can leave it there, which is your, so Stefan, what is that? What do you call that?
Router.
A router, what do you call it, Endo?
Router.
A router, what do you call it?
Router.
Okay, router. I'm trying to get what vocabulary you use to talk about this. What do you?
That's a multi-function device.
It is a multi-function device, that is true. What do you call it? A router?
Router.
Okay. You all know that that is, when we say that this device, when I pull this up, and this is a Linksys E3000. It's an older version of these multifunction devices. Very common. Most of you are comfortable with some of the aspects of it, but we're going to deep dive into it and really get an understanding of what it is. So number one, it is not a router. Okay. It really is much, much more. So if you were to open up this guy, take it, crack it open, you take the 4 screws out of the back, this is what's actually inside. And what we have here is we have a series of antennas. Over here we actually have 3 antennas, and they look very flimsy and cheap, and they are, but believe it or not, there is a tremendous amount of science and engineering that goes in to their specific design. So although they're just stamped metal and they've got attachments to it, they are not just stamped metal with attachments to it. They are very thoughtful, carefully engineered pieces of metal that function as very precise antennas. And we have antennas for the 2.4 gigahertz frequency range, and we have antennas for the 5.5 gigahertz range. Inside also, you've got a couple of metal shielded areas on the circuit board. You've got capacitors, and you've got inductors and a couple of other things. You got a Broadcom chip here that takes care of the switch. There's a switch there, a 4-port switch. There's also a embedded chip here that's got Linux in it. It's got a Linux embedded. This is much like your firmware on your motherboard. It also has another chip that's designed for the radio for the 5 and the 2.4 gigahertz radio. So here you can see the leads coming in. You got 3 leads coming in. This area is very carefully designed RF circuitry. It's really RF radios, RF receivers, and they shield it. The reason why you got this metal around it is they shield that very highly sensitive radio equipment. Okay? If they don't, it can be influenced by external RF radiation. We have lots of RF radiation all in the air, and this metal frame really secludes it and protects it from RF energy that could interfere with its operation. We have a couple other chips that are for various reasons, but the bottom line, this is really in all simplicity, and I'm going to break it down. This is a Linux server with a Broadcom chip and a wireless access point. Okay? So I want to draw I'm going to draw a couple different diagrams so that you can take a look at and get a better understanding of what this really is. So let me do my first drawing here, and I'm going to draw in terms of a Linux server. So, and let me start with this. Let me identify it. This yellow connector is what we call the internet connection. So I'm going to refer to that internet connection, and most of the things I'm going to draw on this piece of paper are all inside. They're not, you can't see them. In other words, you can't hold it up or twist it around and see them. So one of the things you can see is this port right here, and I'm going to identify that as I begin to draw. So one way I could draw this device is draw it like a server, And in reality, this is a server with two network cards. This is a NIC, and this is a NIC, and this is a Linux server. Everybody okay? This is the internet connection right here. So this is, when I point to this network card, I'm really talking about that yellow internet connection, okay? Inside the Linux is all kinds of functionality, and we're going to get into that. Then on the other network card, we go out and we have a switch. And I want you to look very, very carefully when I draw this switch. Let's say this is 1 port, 2 port, 3 port, 4 port. And you're going to notice I've in my crude artistic talent, I have drawn 4 ports on the switch, but I'm going to show you there are many more ports, but they are not visible and not accessible to you. So the Broadcom chip that allows us to have this switch, it has many other ports, but they're connected to other devices. So one of those is connected right here. So we've got a patch cable from this NIC to this switch port. This one you don't see. So all of these switch ports that I'm going to draw right up to there, you do not see these, okay? They're internal. Everybody there? They're there, believe me, if we go trace the circuit board, we can find them. The other is we're going to have a 2.4 gigahertz radio. And we're going to have what? A 5 gigahertz radio. Yes, we are. We're going to have two radios, and this is very typical with most access multifunction devices you buy today come with what they call dual band. What does that mean? That means you have 2 radios. That's what that means. So this is a 5 gigahertz radio. So in reality, you have wireless access points or radios, you have a switch, and then you have a fully functioning Linux operating system. And a lot of our functionality is going to happen right there in Linux. Then we have 2 network cards, and this is where we connect, we can connect here. We will connect to our ISP box. Let's say this is the box that the ISP brings in. This could be Bright House, this could be Comcast, this could be CenturyLink, yes. Okay? So it could be a number of ISPs. They're going to bring some kind of device to your, and you're going to connect an RJ45, yes, to their box and then to the first NIC of this Linux server. And that is represented by that internet port right there, okay? Is that, so I want you to understand, in reality, that drawing is more accurate than any other drawings that I'm going to do. But you still don't really understand it. But that is really what you got. Inside that plastic box, that's it. Okay? Now, inside Linux is going to be a lot of additional functionality. So let me break it down, what's happening inside the Linux server, if I may. So I'm going to keep this here so you can still see it. And I'm going to start drawing in more detail logical blocks. So number one, we have a router. Everyone understood that there's definitely a router involved, but prior to the router is a firewall. Then there is a router. Then out of the router, and this, by the way, is our internet connection point, our yellow internet connection point. Out of the out of the router, we have a DHCP server. We also have inside, functionality inside this. Let me change colors, that will help just a little bit. Inside the router is also our NAT, our network address translation table. So inside this Linux operating system, we're gonna have a firewall, we're gonna have a router, we're gonna have a network address translation table. We're also gonna have a DHCP server. All of that functionality that I just showed you logically is where? Is right inside that Linux operating system. Then we're going to get into our switch. Again, 4 ports are exposed so you can see them. The rest of those switch ports you don't see. This is the 2.4 radio. This is a 5 gigahertz radio. And so now I've broken the multifunction device into even more logical construction. This is actually represented, all of this functionality is actually part of the Linux operating system. And this is embedded Linux. So really everything that I show here is all inside that Linux operating system. So this is, so you can see we're talking about a firewall, a router, network address translation, DHCP server, a fully functional switch. This is a layer 2 switch. We see 2 radios, and that is what you buy for $90. It's all built in. It's incredible. Now, we have all of these pieces of equipment on our campus, but they're separate. In other words, we pay $3,000 for that device right there. Ouch. Okay? We would spend probably, in fact, this functionality is built into our $3,000 router. So our DHCP server on this campus here at Winter Park Tech is actually, this functionality is actually built into our $3,000 router. And we have a lot more functionality into our router. Our switches are all over the campus, okay? So our switches, our cheapest switches, probably start at about $3 grand each. And we have probably 30, okay? Chunk of change. So our switches run about $3,000 a pop. They're usually 24 port, 48 port, depending on the one you buy. Our wireless access points are individual. We have them up on the ceiling in the lab. So whereas when you buy this, you're buying a multi-function device with a lot of the same components that we have on this campus, but they're integrated, manufactured at an extremely low cost, and given to you. Now, here's the beauty of all of this. If we would walk back in time 15 years ago, you guys didn't have this. You really couldn't study networking at home. Guess what? Now, with a multifunction device like this, you can study networking as much at home as you do here in this campus. That is a huge leap for the student technician who really wants to start understanding networking. How do wireless access points work? How do DHCP servers work? Because 15 years ago, you couldn't have this, okay? 15 years ago, you were dialing up to AOL, okay?
I remember that.
Okay? 15 years ago, you were dialing up to AOL and you were happy. I would not be happy today to dial up to AOL. So today, you actually have all the major components that today's basic network systems have, and you have it for $90. Or if you're real cheap like me, you can buy it used or refurbished at half that price. So what was very difficult for you to study and learn and grasp and get a good idea of 15 years ago is now something you can do very, very readily with just very inexpensive components. So now what I'm going to do is I'm going to walk through, I'm going to talk a little bit about these components, and then tomorrow when I get here we're going to start delving into the software. How do I see that when I go into my multifunction device and I look at the software? How do I look at the software so that I understand what component I'm working on and what component I'm dealing with? So let's take a look. I'm going to go back up to my
Those antennas from radio, they have specific functions. I mean that they are different frequencies because of something, right?
That is correct. So there is a spectrum of, there's a frequency spectrum. So if we go look at radio spec, in the world of radio spectrum, here's the United States. Let's go view the image. This is all the spectrum of radio transmission that is allowed in the United States. And notice it's pretty carved up. If you look at this legend over here, you would see that the red is mostly probably the U.S. government. The military owns a huge amount of spectrum. There are slices of radio spectrum that are given to the public. Very little is given to what we call unlicensed public spectrum. In fact, 2.4 and 5 gigahertz are one of the few areas on the radio spectrum that are unlicensed. You don't have to have an FCC license to work on the gear, to set it up and configure it. Anybody who works on these frequency spectrums must be an FCC licensed technician. You get to work on 2.4 and 5 gigahertz frequency spectrums where they're unlicensed and unregulated and they're open to the public. So, radio control planes, drones, everybody in the world is in your 2.4 or 5 gigahertz spectrum. Okay? So in that radio spectrum is where we can transmit radio. Everybody else is either owned by the government or buys it. So AT&T owns a chunk of this, T-Mobile owns a chunk of this, Sprint owns a chunk of this. But I will tell you, out of the spectrum of radio frequency that you can use, they own very, very little. And they pay big, big bucks to own it. Okay? Most of that is U.S. government, satellite, weather. The Defense Department owns probably 80% of all spectrum. Okay? So those antennas that we're looking at are precisely designed. I mean, listen guys, when I say this is, the guys who designed this stamped metal are brilliant people. When you talk about an antenna engineer, you're talking about one of those species of humans that go look at an RF Engineer magazine and look at the math, look at the stuff that they talk about. It's way above the normal human being. These guys are bright. Now, just because they make it out of stamped metal and they make it extremely cheap, doesn't mean that it's not very, very incredibly bright people that are designing it. So these are designed precisely for 5 gigahertz and 2.4. And although they're made of stamped metal, trust me, they did every element of that design is very precisely done. Okay? We would call this black magic. When you start getting into gigahertz frequencies, antennas, it's black magic. It's really amazing stuff. Okay? So although it's cheap, it's amazing stuff. Okay? Any other questions while we're here? Another thing, these normally get relative, the hottest components in here are typically going to be the RF radios, the radios that are generating the RF, the 5 gigahertz and 2.4. Most of the components are relatively low heat. But if you get into, and I believe this is where the RF transmitter is, this is going to generate the most heat. And they're only spec'd for so much power. You can, in fact, you can look in here, if you go and look at the, a lot of guys go in here, they take these off, they put heat sinks on them, they crank up the power, they crank up the current, they even put fans in here so that they go from a half a watt of power output to maybe 2 or 3 watts of power, which is significantly more. In other words, if you outputted a watt of power from this access point, you could probably see it maybe 1,000 feet easily. You could see that access point. Okay? Your neighbors will not love you. Okay? Because you're going to be interfering with a lot of radios. Okay? So a lot of guys go in there and they modify that, but they're unlicensed. They can get fined by FCC because they have modified a piece of equipment, they're not licensed, they don't know what they're doing. So there's lots of guys that go in there and modify this stuff and they tell you what to do and they put fans in them. They actually take these antennas out, they put large dipole antennas on them, they do all kinds of jury rigging, okay? So that they'll transmit longer distances, okay? So you can, if you look, just go online, you can see all kinds of weird stuff. Whether they work or not, I don't know, but they look cool. But that's the standard device. So when you see, now I will tell you one thing about this design. When you put your antennas inside the case, it lowers the cost, but there is a compromise on the radiation of the antenna when you put it inside this plastic box. It's actually better to have the antennas outside and out. But why do they not do that? It's more what? It's more expensive. So to create a dipole antenna is more expensive. And so knowing you guys are cheap, like me, they try to lower that cost as low as possible, so they put the antennas internally. There is antennas in there, but they're internal. But I will tell you, that's a pretty good compromise. I prefer the exterior antennas. You're going to get better transmission, just by and large. Let's take a look at the specs. The CPU in this is a Broadcom chip. Clock rate is 480 megahertz, not very fast. It's got 8 megs of flash. Now, when we say 8 megs of flash, that simply means that the ROM, the firmware, it's got 8 megs of Linux code in it. That's what it means. So when we say ROM, that's Linux. Okay? So it's got an 8 megabyte ROM, and inside there we load an embedded Linux. Okay? RAM, 64 megabytes. And what it does do with this memory, it does shave off a chunk of that memory and make it a temporary hard drive. So when you boot up, every time you boot up your multi-function device, it takes a chunk of that and makes a drive, makes a physical C drive, so to speak, and the rest of it is used for RAM. So the operating system, the Linux, runs in the rest of RAM. You can see that we've got a couple radios. There's your speed. All your antennas are internal. It's got a 4 gig switch port that's available from the outside, and it has a USB, and we'll talk about that in a little bit. So that is the functionality. That's what's going on inside. So before I go on, I want to make sure, let's go take a look at this. I just want to make sure that everyone feels comfortable with the drawing. Anything about this, come on, you can do it, I know you can. Anything about this that you'd like to ask questions?
That means it's a good idea to unplug it, like, eventually you have any problem, it's working good, but unplug it, wait a little bit and plug it again to restart everything, or meanwhile it's working good, just leave it like it is?
Great question. If I'm gonna go away for a week, I'm gonna probably unplug it. But generally, maybe once a month, unplug it, force it to reboot, force it to reset. But the design, this Linux embedded operating system, is so stable that you rarely have to reboot it. They use the same thing in this box. So the ISP box that you get from Bright House or CenturyLink, or they use embedded Linux in that also. It's just a very, very stable operating system. They use a very similar type of embedded Linux that in this box that they use in this multifunction box. So generally, no, you don't really have to do anything. I just purchased a brand new multifunction device, and I'm having to reset it about every 4 or 5 days, which is very aggravating. That tells me something's wrong. So I gotta get it ready and I gotta ship it back. So you really should not have to reboot it or reset it, but just maybe once a month. I would do it just to flush it out and reinitialize everything. Any other questions here? All right, so let's go back here. We talked about the OSI layer, and I want to show you where each of these components is in the OSI layer. So we talked about the OSI layer. This is the physical layer. This is the I'm waiting. Data link layer. This is the transport layer. This is they're flying. I'm sorry. This is the network layer. This is the transport layer. This is the session layer.
Presentation.
Very good. We're getting it. We're slowly. And our application. So we got, this is our OSI layer, 7 models. This is physical. So I want you to look at this multifunction device and tell me what is at the physical layer.
Hardware.
Exactly. We see the jack right here. Everyone see that? So this jack would be at layer 1. Yes? What about these other jacks? Yeah, they're really at layer 1. So this is all at layer 1. All the jacks, the external jacks, are going to be at layer 1. So that type of stuff is going to be at our physical layer. What about the data link layer? What components are at the data link layer? Okay, so let me help you a little bit.
Network interface.
All switches. So this is a switch. This is going to be found at data link layer. This is a layer 2 device. So switches are layer 2 devices. So that is definitely going to be at layer 2. Anything else at layer 2? I'm just throwing it out there. You're not supposed to know this. I'm just pulling to see who. Okay, another layer 2 device are those radios. Those radios are 802.11 standard. All of your radios are layer 2. So when you think of wireless, listen to me carefully. Wireless is layer 2. All your switches are layer 2. So physical, jacks, plugs, cables, all your Cat5 cables that you plug in, all of that's the physical layer. What about the network layer, layer 3? So this is layer 1, layer 2, layer 3. What's at layer 3?
DHCP system.
Not yet.
And that?
Network interface.
Let me tell you what definitely is layer 3, and that is your router. Your router is always going to be layer 3, so this is going to be layer 3. Good question. A couple comments was NAT a layer 3? You know, that's a great question. Where do you think the firewall is in the OSI layer? Where do you think the firewall is? Any guesses?
Session.
Application.
Actually, this particular firewall that's in your typical home router, your typical home multifunction device, most of your firewall is going to cover, watch carefully, so your firewall is going to be a multi-layered device that's going to cover from data link layer to application. So you're going to be able to control what goes in the data link layer, the network layer, the transport layer, the session layer, the presentation, and the application. So this firewall is pretty inclusive. So when we look at the various logical components, that's where they fit in the layers of the OSI. Data link layer plays a big role in the multifunction devices because it represents the switch that's actually behind those connectors, and those access points. We call these WAPs, wireless access points, WAP. So layer 2 is switches, access points. Layer 3 is definitely the router. Remember, router is going to be layer 3. As we get into the other functionalities, firewall spans a number of layers from data link layer all the way up to application. So it is going to allow you to control what goes in at those various layers. And that is a good picture of most of these devices. Now, today what they're doing is, because Linux is the main operating system that's running typical multifunction devices, as vendors try to compete one against another, they're going to adding more and more Linux functionality to your home router, okay? So since they're using Linux, and Linux is very functional, has lots of functionality and features, one of the ways that I can differentiate my router from brand X is I began to add more Linux functionality to your home router. And that is, in this case, where this USB devices connector is. They're actually going to give you the ability to take Linux and not only get all of this kind of functionality, DHCP server, a firewall, a router, and all of this functionality, but now they're actually going to produce a Windows server. So we're going to use Linux to create a Windows server. So I can take and plug an external hard drive right here, put my videos, my music, stick them all hanging off the side of this router, and everyone in the home can access those files, just like a server does. Remember servers and shares? We're going to tell Linux, I want you to act like a Windows server. How do they do that? We talked about that. How does Linux act like a Windows server? Did we forget? Ouch, so soon. Let's go. How does Linux allow us to act like a Windows server? What does Samba do? Samba is an open source software that when you install it on Linux, it makes it look just like
Windows.
So that's exactly what they're doing now. They're actually embedding into the Linux operating system a version of Samba, so that the Linux operating system, you can now plug in a large hard drive, put all your movies, your music on it, and everyone can look and see that server and the music and the videos from any PC in the home.
How do you add to it? Like, do you add to it from, like, your computer, or do you have
Yes,
to
you
take
could.
that and
It-
plug it in your computer?
Just like I could do this, if I go the same way that I would, for example, let's go to a Windows server, a real Windows server. So I'm going to go to your web server, BWP-B126.
So like pretty much all of the house has access to it, but it's not really plugged into the computer?
Well, what I can do is
Add and
I can
delete
plug
something?
in this external hard drive and share it to the network like a Windows server, and then I can say, this user has read and write access.
Oh.
But everybody else can only have read, okay? So I don't have some wonderful family member go in there and delete all the movies on the external hard drive. So just like these shares, okay? This is a real Windows server, and these are shares that are off that. Well, how would I get more videos on there? Well, I would copy them from my laptop to the share. The same thing, I can copy them to the external hard drive.
Yeah.
So I can put music on it, I can put videos on it, and then I can give rights, okay? All family members except me can see only, okay? Can read only. But I will have write permissions. I can add content, delete content.
How do you like set up who's the boss? Like who?
That will be under the firmware. We're going to get into that in the next presentation. I'm going to actually go into the software of this multifunction device and say, okay, when we get this software up, how do we know what part we're working with? How do we know when I'm working with the WAP? How do I know I'm working with a router? How do I know I'm working with a firewall? How do I know I'm working with that? So as we get into the software, we'll actually see firewall settings that we can change. We're going to get into the server where we share something and who has rights, who can look but not touch, who can add files and remove files, okay? So in the software of the router, which is, it looks something like this. I think I have. So as we get into the software section and we start pulling up those web interfaces that some of you are comfortable with, I'm getting. So this is a very blurry graphic, but we're actually going to go into the router and we'll look. And these tabs and various things allow us into the router, allow us into the firewall, allow us into the wireless access point, allow us to set up the server and share things and set permissions and rights. So in that interface is where we're going to control all those multifunction devices. Now, the reason why I am starting down this road is because you can do with these cheap $90, $80, if you want to spend $230, you can spend whatever you want. With these devices, you can do at home all the things that we do with complex networks. Everything that we do with very complex companies and their networks, you can do with this. That makes these phenomenal. So for the student of IT, you can buy something that's cost effective that you can afford and actually start playing with this as complex to networks as we do with $3,000 routers. Okay? So it's all there. One last thing before we go, before we end this lecture. You can DDWRT is a group of open source programmers. It's a group of open source programmers who write replacement Linux firmware. So when Linksys designed their firmware to run this router on all the devices, they uploaded it and they give you a certain interface and certain functionality. This group of programmers write they write Linux embedded firmware that you can upload and overwrite what was shipped to you. And you get all the functionality of DDWRT. So what do you get with DDWRT that you don't get with Cisco's firmware? A lot, okay? So they give what typically most home users want and need. But from an IT student perspective, what DDWRT does is gives you like 10 times more. So whereas you can only do certain things with your router, with the Linksys firmware, DDWRT gives you all kinds of routing capabilities. Where you can only do certain things with your wireless access point, DDWRT is going to allow you to do a lot more things with your wireless access points. So one of the things I encourage students to do is buy used, refurbished, cheap routers like this. Get them and upload a compatible Linux firmware up on their device, and now you have this rich, full function, incredibly powerful platform to learn networking. Okay? We won't get into that right now, but I will show many, many times. I'll show you what you can do with DDWRT that you can't do with this. Okay? And everything that you can do with this kind of firmware gives you the power of doing things at home that you have to be able to do on a real corporate network, like VPN. You folks, no one is going to allow you into their network without VPN, some kind of VPN capability. So no business is going to allow their people to be at home and get back into their network without VPN. Well, Linksys doesn't give you that ability. You download their software and they give you all kinds of functionality for VPN. So you can actually be here at school and VPN back into your home, right into your router, right into your network in a very safe, secure method. Okay? That's for another lecture. Okay? So, great thing to do is start, occasionally go and start learning a little bit about DDRT. You can go to YouTube and start looking at some of the great videos they have so that you're aware of some of the functionality. Not every home router supports DDWRT. They have a whole database, router database, so you can look and see if the one that you're going to buy supports it. So you can check out and see if your router supports DDWRT, and if you feel bold and brave and you want to overwrite your firmware with DDWRT, you can. The best thing to do is just to buy a cheap refurbished one for 30 bucks, 40 bucks, upload a DDWRT firmware on it and start playing with it with something that's not critical in your home. So if you blow things up, everyone in the house doesn't hate you. Okay. What did you do? You're playing with the home access point again. Okay. Questions? Yes.
Oh, you're looking back there.
Yeah.
No, go ahead.
How would you access the firmware on it to change it?
We'll get into that when we get into the software tomorrow. We're going to jump in and we're going to take a look and drive around the software a little bit. The software actually has you the ability to update the firmware. So Cisco may find a bug and say, oh, you need to upload the next version. With that same ability, we can go to DDWRT and upload their firmware. It overwrites what's there, and all of a sudden you've got this fully functional, phenomenal device. It really is amazing. Okay? Yes?
When you were talking about those layers,
The Samba, do you upload that on your external hard drive?
You don't have to do, because DDWRT is going to have Samba built in. And guess what? This one has Samba built in. So it's already baked in. So anytime you see the USB port on your multifunction routers, they've already embedded Samba in their Linux firmware so that it can act and look like a Windows. This already comes with it. Now, if you install Ubuntu has Samba baked in. The Mac OS has Samba baked in. So it's really hard to find a Linux version. You'd have to go look for a Linux version without Samba. It's almost a given. Okay? So you'll have to go look for a version of Linux that doesn't have Samba. Does that? Any other questions? So what are these? Multi-function devices. They're really not a router, and you can see that now. There are really lots of them. So I want you, one of the things that I want you to be able to do is, when you walk away, I want this understood. Let's go take a look real quick. I want you to understand the logical components of a multi-function device. Number one, it's going to have many logical components. One, it's going to have a firewall. Number two, it's going to have a router. Number three, it's going to have a network address translation table. It's called a NAT. 4, it's going to have a WAP, wireless access point. Number 5, it's going to have a DHCP server. Number 6, it could have a Linux Samba server also. This is where you're going to be able to share videos and music via a USB external. It's also going to have a switch, a full function layer 2 switch. And I think I got it all. So that is the logical components in your typical multifunction device. Now, depending on the price you pay, you may get better functionality in these areas. So if you buy the latest, greatest ASUS router, multifunction device, you may get a much better radio, a much better access point. If you buy less expensive ones, for example, I buy at least one very inexpensive multifunction device, and I just keep it a spare. So if my one that I live and breathe and die on dies, I can take my cheap one and stick it in temporarily till I can go out and get one. Otherwise, my wife would kill me. She can't have her iPad, I'm dead meat. So I've got a spare ready to go, okay? It's all set up and configured. All I gotta do is plug it in and go.
How long do those normally, how long do you normally keep those for?
That's a great question. I probably wouldn't keep them any more than 3 years. Because in a 3-year period of time, the radio technology, the router technology, the Linux technology has so radically improved and changed, it's worth it to buy one. Now, let me ask you another question. How do I go out and choose the ones I buy?
Yeah, I do reviews.
I'm going to go to reviews, and I talked about that. So when I go buy a device, and I don't care what kind of device it is, let me show you how I go buy devices. Mr. Interval does not know everything. I need the experts that are out there that do the reviews, that look at this equipment. So I typically will go to, one of my favorite is CNET, because they really focus on reviewing consumer products, and this is considered a consumer product. So I will go look at the top routers out there. I'll go take a look at them, and I'll look at the reviews. And generally, when they review them, I will look at the top 3, and I will say, what can I afford? Because some of them are beyond what I want to pay. I don't want to pay $280 for a top-notch router. But number 3 was rated very good, had a lot of great features, and number 3 is was well liked by the reviewer. Okay, then I go find the best price I can buy it, and that's how I buy everything. Everything. I go to people that are experts. I look at their reviews, and then from the experts, I then figure out what price range can I buy. Then I go search for the best price. And I buy everything, guys. Cameras, Blu-rays. I don't know all this stuff. I go to the experts. And based on their reviews, look at what I can afford, and from that, go find the best price. And I rarely get burned. I mean, I've been burned a couple times, but generally I'm very satisfied with that process. So when someone says, oh, this is the best in the whole world, go check it out. Go get the expert reviews, somebody that knows what they're doing, knows what they're talking about, who has thoroughly reviewed the product, and then go from there. Don't just take on what Joe said. He just bought one and he says it's real good. No, go to people that know what they're talking about and understand this technology very, very well, and go from there. And you can generally get a very good deal on almost any consumer